Hello and welcome to CSM Today. I'm your host, Melissa Braun, and tonight I will be joined by the members of the CSM Talents Robotics team. We'll be right back. Welcome back to CSM Today. I'm here with the members of the CSM Talents Robotics team. Hey guys, thank you so much for coming. Would you mind introducing yourselves and saying what you do on the team?
I'm Edward Gesser. I do a lot of design and robot building on the robotics team.
I'm John Hamill. I'm director of the programming and some of the design as well.
Great. Would you mind telling us how you got into robotics?
That is a very long story. I've been doing robotics for the past 11 years. The first time that I went to a robotics competition was actually here at CSM. That's really how I got interested in it. It was a very interesting challenge.
Ed?
I had a very short stint with robotics in 7th grade, and when I got into high school, I decided to join the high school's robotics team. And I wasn't really that interested in robotics then, but after being in the team for 4 years, joining various other robotics teams, I basically decided that I really liked robotics, and so I wanted to continue to do robotics here at CSM.
That's really neat. So was there anything that you think you really got from doing robotics for so long?
For me, it's more seeing the applications of what I'm learning in classes. Also a little bit of programming, which is something I was really unfamiliar with in the beginning, but I'm getting somewhat better at it now.
That's cool.
Robotics has definitely given me an interest in engineering in general, and it's given me a lot more mechanical know-how than I started out with. It's also taught me a lot about programming, especially in C-based languages. So it has also boosted my confidence and my capabilities of wanting to be an engineer in the future.
Right. So it's not just building the robot, it's also programming it? So how does that work?
Well, we currently, the programming aspect of the robot is a lot of trial and error, actually. For what I do is I look at previous programs that have worked in the past and then cut and paste sort of what's worked and seeing how I can adapt it to what we're doing now.
Oh, that's really neat. That's really cool. So is this the robot that you guys have been working on, or?
The robot that we're currently working on for this year's competition, its design is kind of classified in order to keep it from falling into the hands of enemy teams. But this robot is our demonstration robot to kind of show other people what we do.
Right. So you demonstrate this out for other people?
Yes.
Right.
Just recently, a few weeks ago, we actually demonstrated the robotics at the entrepreneurship down in Indian Head. It was a very interesting crowd.
Do you want to elaborate on that?
Well, I got to meet the mayor, who I'm actually older than. So.
Oh, wow.
Yeah.
So what sort of things did you demonstrate down there?
Mainly it was robots that we had built for, other robots we built for demonstration, little Vexed bots. They're only about this big. They're really small, and they are used for actually middle school competitions.
Oh, cool. So there's different types of competitions?
Yes.
There's like a middle school and a high school league, which is, I think you started in middle school and high school league with Vex. And a lot of our team members have done the same, start middle school and high school league. And there's also Vex U, which is the college league, which is what we're participating in now.
Oh, cool. That's really neat. So, is there one thing that you think a lot of people would get from robotics?
Gray hairs. It can be fun. It can be stressful. It can be educational. You can see a lot of interesting designs and maybe ways you can fix things around your home, maybe.
The interesting thing about robotics is there's a bunch of different things that are involved in robotics. It's not just building. You have building for engineers, you have programming for computer scientists and engineers. There's also documentation, which is very important. And things with managing the club, like managing a budget. Some people that are in, that used to be in our club actually aren't computer science or engineering majors. They just saw the other things in robotics besides engineering based that they thought they could benefit from, and they did.
Oh, cool. So after you've left robotics, do you think you can see yourselves going on into the same type of field?
For me, something very similar. I was hoping to get go into biomechanical engineering, which is more prosthetics and exoskeletons.
Neat. And how about you, Ed?
I definitely want to work specifically in robotics in the future. I want to either work at the Pax River Naval Air Station as a robotics engineer, or even at NASA Goddard Space Center as a robotics specialist.
Cool. And what sort of things that robotics do you think can apply to real world outside of competitions?
One obvious application is combat. UAVs and unmanned ground vehicles are going to be the future of the armed forces. They got a long way to go, though.
Yeah.
A lot of space exploration stuff. The stuff that I'm really interested in is robotics applied to space exploration. Like, we're exploring Mars with the Curiosity and Spirit and Opportunity rovers, various other robotics missions to other planets. Robotics has a lot of applications everywhere, both on and off Earth.
Right. So what you're saying is that someday we could be seeing a robot manned and operated, or maybe built by one of you guys, going off into space.
That's what I'm shooting for.
Well, thank you guys so much for coming, and it's been great talking to you. We'll be right back with more from the CSM Talents.
If you don't fix them, sparks from dragging tow chains could cause a wildfire, and that could be scary.
Bye, Smokey.
Only you can prevent wildfires.
Welcome back. We're here again with members of the Talents, and they're going to show us a little bit about this robot that they built. So would you guys mind telling me a little bit about the design of this? You said it was a demonstration robot?
Yes.
I'm going to turf that to Ed. He was mostly the person who built it.
This robot was generally, its purpose is to be able to manipulate a wide variety of items. The tracks were just an experiment to see how well tracks works. Most of the time we use wheels, so I wanted to see how effective tracks would be in a robot, and they've been pretty effective. We have an arm here that lifts up and a claw that can go up and down and can open and close. And so it's designed to be able to interact with people that it's demonstrating. It can pick up objects, give objects to people. We've had it in the past demonstrating to people pick up pieces of candy out of a bowl and actually hand it to children, and they get a kick out of that. At some points during a STEM expo down in St. Mary's County, this robot we were able to have the kids control it and get some experience with moving the robot around.
So you mentioned that children can show it. So basically, is it easy to control, or?
It's fairly easy to control, yes.
So you mentioned it about picking up different objects. Is there like a weight limit, or?
The main problem is the arm is very strong, but the actual servos here that make the claw go up and down are fairly weak just because of the design of the servos. So I would say the maximum weight that it can lift would probably be about ½ pound.
Oh, cool. So would you mind telling me a little bit about how the design worked? Because this arm looks really interesting.
This arm is called a parallel lift. I believe it's a 6-bar version. And so these are the motors that lift up the arm. Here we have a gear ratio which gives this arm lots of torque. Here we have a small gear and a large gear, which gives the arm a lot of power, but in sacrificing speed. So basically these levels, the way they're screwed together, right now they're folded down, they're quite compact, but when the arm is fully extended, it's actually can be about this high off the ground. And at the very end it has here the servos which move the claw.
So it moves the claw up and down?
Yes.
And I'm assuming this motor allows it to open?
Yes.
And you mentioned this has tank treads. So is there different types of wheels that you could have on a robot?
There are a variety of types of wheels, as a matter of fact. There are wheels that you can use for a little more grippy. There are Omni Wheels, which are actually wheels on wheels. So they are wheels that allow you to strafe as well as move forward and backward. There are also wheels that are called Mecanum wheels. They allow you to use 4 motors. Normally, when you're using Omni Wheels, you would require at least 5 motors in order to strafe. With Mecanum drive, you can strafe with only 4 wheels, but you have a sacrifice of power.
All right. So you mentioned power. So these are battery-driven, charged, or?
Yes, they are operated by 7.2 volt batteries, which they go through quite quickly.
Yes.
So I imagine you spend a lot of times, like before competitions or before demonstrations, just charging the batteries?
Yes. We're developing a system now that in order to have a new fresh pair of batteries each time we have a competition, we have a box that's charging 8 batteries simultaneously so that whenever we need batteries after each competition, we can just grab brand new ones and put them in.
That sounds very, very resourceful and probably saves you a lot of time.
Yes.
Right. So earlier you mentioned something called torque. Would you mind explaining what that is?
Torque is basically rotational strength. It allows you to rotate heavier objects or harder to lift objects.
Okay, and you mentioned something about how a smaller gear that's rotating into a larger gear will create strength. Will the reverse create an opposite effect, or?
Yes, but you do sacrifice power, and a lot of it. It can be very useful to have extreme gear ratios, but sometimes it's more useful to either not gear them at all or have them directly driven to the motors.
All right. I notice you have a little flag on your robot. I was wondering, what is that for? Does that have a specific purpose, or is it just pretty decoration?
It's just there as kind of a symbol and a decoration. We've seen lots of different robots in international competitions that, you know, have the American flag on there, and I just kind of have it on there to represent and look nice.
Right. So you're allowed to have decorations on your robot in some competitions?
Limited,
Limited,
yes.
These decorations, of course, are decorative. They're not supposed to interact with the game field, other robots, in any sort of manner. They're just supposed to be on there and not serve any purpose. Like I remember last year, there in the high school competition, someone had a model of the USS Enterprise on their robot, and it was really cool.
That sounds amazing. What is the strangest decoration you've seen on a robot, do you think?
Ooh.
That would be a tough one. I've seen a flaming pickle. I've seen googly eyes, oddly enough.
Googly eyes?
Yes, googly eyes. The little eyes that shake around? Yeah. Very large ones.
That sounds amazing. Right. Is there anything like super special about this robot that you're really proud of? Anything that's like you think is super innovative or that gave you a little bit of problems trying to innovate?
I think the thing I like most about this robot is the way it's driven. Each side of the track has 2 motors. Usually when we build robots, each motor is connected to each wheel. There are 2 wheels on this track, but if we were to put a motor here, it would interfere with the arm. So instead, in order to have 2 motors drive the wheel, but without having it driven on this side, we have a chain drive that provides power from this motor and this motor directly to the robot.
That's really neat. So thank you guys so much for joining us today. We'll be right back with more from the Talons.
So I've come up with a family emergency plan.
Great. What is it?
It's difficult to talk about, so I'm not telling you.
How will we know what to do?
You won't.
I'm so glad I won't have to remember anything.
And me too. Thanks for this, sweetie.
Talk to your kids about who to call, where to meet, what to pack. Visit ready.gov/kids for tips and information.
Welcome back. We're here once again with the CSM Talents. So you guys were mentioning earlier that you were doing these robots and entering them into competitions. Would you mind explaining to me what the competitions were like?
Competitions are honestly very stressful. It's basically when you're facing off against other colleges who have worked equally hard on their robots as you have on yours. And a lot goes wrong. It's really where you stress test your robots and push them to their limits.
Okay. What do you mean by stressing them to their limits?
A lot of parts break during competitions. Pieces fall off, tread pops off, chains break, cortex, your brain that controls everything, sometimes that can get completely bricked.
Oh, geez.
The different thing about the competitions as compared to when the team is practicing is that during competitions, it's every detail matters. When you're driving your robot, you have to drive it faster than the other teams, you have to score faster than the other teams, you have to score more than the other teams. And so all of this strains your robot's capability to the very max. And that's why so many things break.
You mentioned scoring earlier. Would you mind explaining how the game is played?
Well, this year, we are on two separate halves of the field. So this year, the robots almost cannot interact with each other. And we would be, we're tossing these objects from one side of the field to another. Yeah. These objects and a little foam cube, well, not really little, but yes, foam cube across the field. Each star that gets onto the near side of the fence is worth 1 point, where the cube is worth 2 points, and then each star on the far side is worth 2 points, where the cube is worth 4 points.
So basically you're trying to get these little objects onto the opposite side of the field as far as you can.
Yep.
Is there any other ways you can score points?
You're also allowed to hang on a pole at the end of the match, so long as you are more than 12 inches off the ground. At the end of the match, you get bonus points.
Oh, nice. So you mentioned earlier that this year, this was the competition. So are you saying that there are multiple competitions or types of games each year?
Every year there's a different competition. Vex tries to make it different every year so that teams can have a new robot to build, a new goal to achieve. And these games are often so different year after year that you really can't use the same robot. Each year you have to go through the engineering design process again. You have to make a new robot.
Right. So basically every single year you're starting your robot from scratch.
Basically. Occasionally you can reuse the very bottom of the robot, the very basic chassis. Many teams reuse, but usually the parts of the robot that manipulate the environment around them always changes because there's, like last year, the basis of the game was to grab these balls and shoot them into baskets, almost like basketball. And this year, of course, is a much different game.
Yes. So you've both mentioned that you've been in robotics for a really long time. Would you, and so obviously you've probably gone through a couple different types of games and competitions. Would you mind saying which of them was your favorite to be in?
That is a tough one. My favorite would probably have been probably Clean Sweep, which was very similar to this competition, except it was actually scored with footballs, a inflatable basketball, and little soccer balls, which were about 3 inches in diameter.
And what would you do with those little soccer balls?
You put them on the other side of the field and got points.
Neat. How about you, Ed?
My favorite game was Vexed Skyrise. It was when you had these cubes, and these cubes were made up of tubes, and basically the goal of the game was to pick up these cubes and place them on poles. There was also another part of the game where you had little cylinders that you got to stack. The reason why I liked that game so much is mostly because of the team that I had that year. We were a great team, the ideal team. This was in high school 2 years ago. And that year we won the Excellence Award, and we won the whole thing, the regional tournament, for the second year in a row. So it was a great year.
And what do you think was the most challenging year you've had so far for designing a robot?
I would say actually last year.
Really?
Definitely.
Because the parts aren't designed the pieces aren't really designed to operate at extremely high speeds, and that's what we decided to do. We decided to build a spinner, kind of like a baseball shooter, which required 2 flywheels to spin up really, really fast, and then it would shoot a ball really far. The problem is that these things would go upwards of 20,000 RPMs, and the pieces were not exactly holding up as well as they could have.
So basically, they didn't have the durability for.
Not at all.
All right. Would you mind saying what last year's competition was?
Last year's competition was basically taking these foam balls off the ground, picking them up into your robot, and tossing them into a net. Now, the different thing about this game as compared to most other games, so most other games you were allowed to, the main basis of the game was to grab something and do something with that object by putting it somewhere, putting it on something to score. The different thing about last year's game is that it involved projectile motion. You couldn't just take something and put it somewhere else. You had to launch the ball in some sort of manner. Some people use catapults, some people use flywheels, and it was an interesting game, definitely an interesting game.
Sounds really neat. Earlier, you mentioned something about an excellence award. Are there different types of awards you can earn?
Yes. Overall, the Excellence Award is considered to be the highest award at any given competition. There's also the Tournament Champion, whoever wins the elimination bracket. There are also design awards for whoever has like the best engineering notebook and designs. There are lots of different types of awards given at these competitions.
What's an engineering notebook?
Engineering notebook is where you document the engineering design process. A lot of what Vex, as a competition, is trying to do is teach students how to do engineering work. And most engineering, well, basically all engineering, needs to be documented in a very specific fashion. What did you do? What did you build? What ideas did you have? Show all your brainstorming, show your process, and show the different code and stuff that you put on the robot. Everything that you do in order to achieve your goal by making the robot for the competition needs to be documented in a notebook. So the notebook contains pictures, sections of code, sketches, drawings, all sorts of things that describe how the robot was built.
So basically, all throughout the design process, you're documenting what you're doing so you can show it later in the season, I'm assuming?
Show it later in the season to the judges, yes.
So you guys are judged as well as competing in the competition?
Yes. Often these are done by random interviews that the judges will actually walk around the competition floor and walk over to your maintenance area and then start asking you questions.
So assuming a judge would walk in here just randomly and ask you to tell you something about this robot, would you be able to?
To a point, yes. Although I haven't worked a lot with this robot, I would mostly turf it to Ed for that.
Yeah.
So basically, your strategy would be foisting it all on Ed and hoping he knows the answers.
Exactly.
Okay. Well, thank you guys so much for stopping by. Thank you so much to the CSM Talents for stopping by. Tune in next time for another edition of CSM Today.